So, in that last example, one of the solutions can be verified, but the other solution can't be verified. Why is that true? Well, we call it a extraneous root. The process used in solving investigation 2 led to an answer which is not one of the possible solutions. It is, however, a root of the non-radical equation that we created. Well, what happened was, in order to solve it, we squared it. So we got what was the equivalent of negative 3 squared. Negative 3 squared is equal to 9, and positive 3 squared is also equal to 9. So those two, after we squared it to solve it, look equivalent. But the original values are not equivalent, which means that in the process of solving it, when we had to square both sides of the equation, we created an extra solution which is not actually possible. We call this an extraneous solution or an extraneous root. It means that when we need to square both sides of the equation to solve for what x could be, we're creating, because we got rid of the radical, a second possibility for an answer that possibly does not work. So, in this case, it doesn't actually want the solution, it wants what the extraneous root is. It wants us to find the solution that does not actually work. So they got to start it off. They have it isolated. Then they said we're going to square both sides. So then I'm going to get x plus 2 is equal to x squared. Well, I'm going to move everything to the left side of the equation, or sorry, the right side in this case, because I like x squared positive, x squared, and I'm going to subtract x from both sides. I'm going to subtract 2 from both sides, which means that 0 is going to equal, well, the only way I can get this is x minus 2 and x plus 1 when I factor it. If x minus 2 is equal to 0, x is equal to 2. If x plus 1 is equal to 0, x is equal to negative 1. Now, one of these should be an extraneous root when I double check it. So I'm going to try the first one. I'm going to say, well, if I have the square root of 2 plus 2, does that actually equal 2? The square root of 4 is equal to 2. 2 is equal to 2, and that one does work. In the second case, I get the square root of negative 1 plus 2 is equal to negative 1. Well, this is going to be the square root of 1 is equal to negative 1. 1 does not equal negative 1, which means that this is not true. X is equal to negative 1 is the extraneous root. Now, frequently I'm asked, well, why is it that when we're solving quadratics, we wind up with a possibility because we take the positive and negative? So, I mean, the second one should work because it's a positive and negative. Remember, it's only the positive and negative if in the equation it includes plus or minus. In this case, it doesn't say plus or minus, which means that it is only the positive principal square root in the equation. If it wanted both of them, it would have to say plus or minus, or if it just wanted the negative one, it would have to say minus in the equation. So, the steps for solving these algebraically. First, isolate the radical. Please, please, please remember to isolate the radical. Otherwise, when you square it, you will not get rid of the radical, even though it looks like you might have. Square both sides of the equation, solve the equation, and then verify answers because you might have extraneous roots. You got to prove that whatever answers you get are actually correct. So, in this case, I have square root of x plus 3, which is already isolated squared, is equal to 7 squared. x plus 3 is going to equal 49. And here I just get one solution. X is equal to, when I subtract 3 from both sides, 46. Well, let's just check and see if this works. The square root of 46 plus 3 is equal to 7. The square root of 49 is equal to 7. 7 is equal to 7. And this is the correct solution. In the second case, I got to isolate this, which means that I'm going to say the square root of 49 minus x is going to equal, I got to move the 7 over and get x minus 7. I'm going to square both sides. Remembering that x minus 7 squared is actually x minus 7 times x minus 7, which means that 49 minus x is actually going to equal x squared minus 14x plus 49. When I move the 49 and the x over, then I wind up with 0 is equal to x squared minus 15x, and the 49 minus 49 is just going to cancel each other out. Oh, sorry. Minus 13x. I'm going to add 1x to both sides. So 0 is going to equal x and x minus 13, which means x is going to equal 0 or x is going to equal 13. Now we got to verify. So the first possibility is the square root of 49 minus 0 plus 7 is equal to 0. The square root of 49 plus 7 is equal to 0. 7 plus 7 is equal to 0. 14 does not equal 0, which means that that's an extraneous root. Check the other possibility. The square root of 49 minus 13 plus 7 is equal to 13. Square root of 36 plus 7 is equal to 13. 6 plus 7 is equal to 13. 13 is equal to 13, which does work. And there's our correct solution. If I have a cube root that I need to solve, I'm going to do the same thing. It's just in order to get rid of the radical, I'm going to cube both sides of the equation because I need to be able to cancel it out. Everything else works the exact same way. So I'm going to start by saying that the cube root of 2x minus 7 is going to equal, I'm going to move that 5 over and add 5 to both sides, 5. Then I'm going to cube both sides. The cube root of 25 minus 7 cubed is equal to 5 cubed. And 2x minus 7 is equal to 125. I'm going to add 7 to both sides. 2x is equal to 132. And we're going to divide both sides by 2. X is equal to 66. Well, now we need to actually verify that this works. So I'm going to take the cube root of 2 times 66 minus 7 minus 5 is equal to 0. The cube root of 132 minus 7 minus 5 is equal to 0. Cube root of 125 minus 5 is equal to 0. 5 minus 5 is equal to 0. 0 is equal to 0. And it does work. And that is, in fact, my solution. That's it for this unit.